All right. Good evening and welcome to Lambda School's mini boot camp. My name is Jess Martin. I work at Lambda School leading our Lambda Fellows program. So tonight we're going to be doing something really fun. We're going to learn about how web servers work today by building one together. All right. Good evening and one thing we don't want to do is hear my echo. There we go. And that would be the echo from YouTube coming in. All right, so as I was saying, we are going to learn about how web servers work by building one together. So I've been writing software for about 2 decades now, and it is a blast. Programming is still one of the most fun things that I can imagine doing. And so if you enjoy programming or think you might enjoy programming, hopefully this will be a fun experience for you as well. So let me go over some quick ground rules before we get started. So what do you need to know to be successful for tonight's session? One, this is a fairly basic programming class. We're going to go for about 90 minutes. Even the term class is a little bit loose, and we'll talk about that in a minute. But basically, in order to be successful tonight, all you really need is very basic programming skills. You should know about variables, function calls, and perhaps importing libraries. It would help if you have experience with object-oriented languages. We're actually going to be using a language today called Java, and Java is object-oriented down to its very bones. So just knowing how to do things like new and create and use constructors and that kind of stuff will be really helpful. So that's all you need to be successful. So my first focus today is, while today is about building a web server, the more important thing I want to demonstrate today is, how does an experienced programmer learn new things? See, there are hundreds and thousands of tutorials out there that show you exactly how to do a thing the right way the first time, but that's not real life as a programmer. So my first ground rule for tonight's session is that this is live. This is not going to be like your typical class at Lambda School. Your typical class at Lambda School would be taking you through a tutorial where the professor or the teacher has already solved all of the problems and is walking through building that with you. I'm actually going to be live coding a web server from scratch, and I haven't figured out the solution completely in advance. There's still lots to figure out. So 2 things that I've picked to make this more of a co-learning experience for both of us. One, I've picked something I've never done before, which is writing a web server from scratch. I've used web servers, certainly, and written software for web servers for a lot of my career, but I've never actually written one from scratch. So we're going to try and do that today together. And then I also picked a language that I don't use every day. So Java is a language that I started out professionally programming in about 15 years ago and really haven't used it professionally in about a decade. So yes, we will be reading the docs together as we learn how to use it. And my intention, why would I do that? Why would I pick something I've never done before in a language I don't use every day? Well, my intention here is to give you a feel for the workflow of an experienced developer. I hate how those tutorial videos that you watch show the developer just going from beginning to end as if they never make any mistakes or hit any bugs or have to Google something or backtrack. The reality is we do not have it all in our head. Even after 20 years of programming, you still have to Google something, you still run into things. And so I wanted to show off the workflow of somebody who's been programming for a little while, but is faced with a new challenge and a little bit of a new language. So that's ground rule number 1. This is live. Ground rule number 2. This will be about 90 minutes long. I don't know how far we'll get in 90 minutes, but we'll see. I tend to work in 25-minute blocks with a 5-minute break in between. These are called Pomodoros. You can Google Pomodoro and look up Pomodoro technique. So we're going to do 3 of those Pomodoro work blocks, where we're going to do 25 minutes of focus time and then take a 5-minute break in between. So ground rule number 3 is, how can you engage? Well, for one, I will be checking the chat on YouTube. I'll be lightly monitoring that during our 25-minute work block, but during the 5-minute breaks, I'll especially be referring to the chat, reading through comments and that kind of stuff. So if you've left a comment in there, I'll get to it eventually and check that out. And the other thing that you can do is, instead of just chatting in YouTube, you can actually code along with me. So I'm going to be working in a little tool called Replit. And I'll show you how it works in just a second. And you can actually look down in the YouTube description at the bottom, and you'll see a link to a Replit site. If you go ahead and open that up, that has kind of like the starter version of our application where we're going to start together. And then as we're going through the live stream and you ever want to catch up where I'm at, let's say like you've been kind of following the YouTube and you'd like to actually be able to see the actual code in Replit, you can just refresh the Replit. It will not live update for you. You will have to refresh it. Or even better, you can actually fork my Replit, which I'm going to show you how to do in just a second, and you can use that as your sort of foundation for programming. So you don't have to install Java on your computer, you don't have to get anything up and running, you don't have to learn about VS Code or any of these editors. You're going to be able to follow along with me and write code right in the browser. So that's the next thing. Let's go ahead and I'm going to walk you through how setting up Replit. I'll share my screen here in just a second, and then we will dive in. Okay, so this is Replit, what we're looking at right now. This is the main screen that you're going to be watching me code on throughout the night. I apologize for the light gray on the comments. I've tried to make this a little bit bigger. If you guys still want the text to be bigger, I can make it even bigger, so feel free to drop that in the comments if you're finding it hard to read this particular text. So what you can do is you can grab the link that's in the YouTube video, and if you grab that, it's the same link that's up here. And if you open a new browser window, what you will see will look like this. So you'll see this basic web server, and there's a little toggle here that says output and code. Right now, this program has nothing but comments in it, so there's nothing to output, so you'll see nothing there. But if you click right here where it says code, you can actually see the code as I'm going through and editing it. And like I mentioned, as I'm writing more code, it will update here only if you refresh. So this will not live update. This is a static representation of like the code that I'm working on. I'm only going to be working in a single file, so you'll only need to refresh this code and you'll see the new stuff. Or you can do this. There's a blue button up here in the top right-hand corner that says fork. If you click that, if you have a REPL account already, you can go ahead and log in. If you don't, it's free. You can set it up with your Google, you can set it up with your GitHub account, you can set it up with Facebook, or you can set up a username and password. If you go ahead and sign up, this will actually clone all of the code that you saw on the screen over to your own REPL that you can then be editing in and actually running as well. And what I'd recommend is as you're doing that, after you do the fork, if you just push that over to the side, you can have the video on one side of your screen and the REPL on the other, and then kind of follow along with me there. Again, if you ever get lost, you can actually fork again and basically start from the perspective of where I'm at. So if any of that's unclear, feel free to drop a question in the chat and we will get right started. Okay, so I mentioned that tonight's class and tonight's session, we're going to be building a web server from scratch. So those words may or may not mean anything to you. What exactly is a web server and why does it matter what a web server even is? So what we're going to focus on today, and I'm going to be working over here at the whiteboard, is understanding how web servers and web browsers work. So all of you are on the internet, right? All of you probably, hopefully maybe, are looking at a YouTube screen right now. You might have just loaded a Replit thing or a Replit link up as well. And that you loaded in your browser. So if you're using Chrome or Safari or whatever, that is a web browser. You probably already knew that. And then as you were connecting to YouTube or Replit, you're basically connecting to a web server when you make that connection. When you go to that link, you are loading up a web server. And you can kind of think of a web server as web servers are just somebody else's computer running an application on it. And so we're actually going to take some time to write that application, one of those web server applications right now. So the reason this is important is there are literally millions and millions of web servers that power the internet that make for our everyday browsing experience, where you can go to a web browser and go around to different web servers. So the way that you make a web browser and a web server talk to each other is actually pretty simple. So you can kind of think of a web browser and a web server as an instance of two cell phones talking to each other. So let's see, let's draw my janky cell phone over here. Think of it as two cell phones talking to each other via text message. So you've got two servers. We'll say that this is our web server, or actually we'll make this our browser on the left. Web browser. And then over here we've got our web server. This is the thing we're going to build tonight. This one. It's going to be pretty cool. We're going to be able to do this in under an hour, I think, which is pretty neat. So you've got a web server, a web browser and a web server. And think of them like two cell phones that are actually text messaging back and forth with one another. And so basically, you've got this guy sending messages over to here and this guy responding. And you can just think of it as like the bubbles in the little chat that's probably on your iPhone or your Android, where this guy sends a message, this guy sends a message back. I guess on the iPhone, it's on the left, right? Or right. And these messages go back and forth, and we call the messages that go from a web browser to a web server the request. It's not really complicated, right? That's the same way we use that word in English, request. And then we call the things that go from the server back to the browser the response. So you could actually imagine this just in the same way that you might request something from a friend via text message, right? You might send them a message saying, hey, are you available for dinner tonight? That would be your request. They might then come back and say, yes, I am available for dinner tonight. That would be the response coming back to you. And that is exactly how web browsers and web servers work as well. And furthermore, when they are communicating with each other, they're also using plain text, just like the text that's in these messages that are going back and forth. And so we're going to look at what a request and a response looks like in this little cycle here. The one thing that's special about the way that browsers and servers talk to each other is they talk to each other in a pre-agreed format called HTTP. They basically said, hey, when I ask you a question, it will be in a specific order. Like each word in the sentence will be in a specific order. When I send you a response, each word will be in a specific order as well. And so all we need to do in order to actually implement a web server is we just need to mimic, like have something send and receive messages using this pre-agreed on format called HTTP. And lest you think HTTP sounds really complicated, you can actually go and read how these things are supposed to be formatted. And we're going to keep it pretty simple by using a very small section of HTTP tonight. Okay, so I mentioned that all we really need to do is know what requests and response looks like. So let's actually write these up on the board before we jump into writing some code about sending and receiving them. All right, so we got a request. All right, so this is the magical, secret, crazy structure of HTTP requests. You ready? It's really, really complicated. All right, so it starts out with a single word which represents what you're trying to do with the request. That's sometimes called the verb. In our case, all we're going to do is the verb get. So the very first thing is get. I want to get something. Remember, I'm a web browser talking to a web server. I would like to get something from this server. And remember, a server is just another computer, somebody else's computer running some software, and that computer has files on it that you might want to get. And so the web browser says, can you get me this file? The very next thing is the file. So it could be, you can name it, you could call it my fave file. There's different ways that you could structure this second thing, but you're basically saying get my fave file. And then the very last thing you need to do is you need to specify which HTTP language you're talking in. So that looks like this, HTTP/1.1. And you can think of this as literally specifying the language that you've agreed upon communicating in. That would be no different than like texting your friend and saying, hey, would you like to go to dinner? And by the way, this message was in English, right? Or, hey, man, I don't know, would you like to go to dinner? Quiero comer, something like that. And this last message was in Spanish, in español. So this is the language that you've agreed to speak in, and that helps that web server know how to parse the response because it knows to expect things in this specific order. Okay, so on to the next thing. Wait, are we done? Is that a request? It turns out you need one more thing, a blank line. Literally, that's it. Requests, this is an entire valid HTTP request that a web browser, like the one that you're using to watch this video right now, might send to a web server. There's a bunch of other things you could add here that are optional that tell the server more information, but you don't need to know any of those right now. This is a complete and valid HTTP request. You have successfully asked for my favorite file from the web server. All right, so let's look at response. Hopefully response isn't much more complicated, right? Okay, Response, you actually start with the language that you're speaking that we talked about. It's HTTP 1.1. That's just the current version of HTTP out there. You start by saying, hey, my response is coming back to you in HTTP 1.1. The next thing you do is you say, you send a what's called a status code, or like, how did the response go? And in general, when you're able to fulfill a request, when you're saying, yes, I have the thing that you've asked for, then the response code is 200 OK. That's it, 200 OK. These status codes, of which 200 OK is one, you can actually go Google HTTP status codes and you'll get a list of a whole bunch of them, but you've probably run into one of these already in your time on the internet. 404. Anybody ever seen 404? I wish that you guys could speak back to me, but I imagine that I would be hearing some people saying not found, right? So 404 is the not found status code. And so when you hit a website and you get a 404 error, it's actually referring to the response that the web server gave back. It gave back a 404 not found. And so that's all 404 means, is a web server wasn't able to find the thing that you wanted and responded by saying, I ain't got it. 404, didn't find it. But the only status code we'll be using tonight is HTTP 200 OK. So HTTP 1.1, 200 OK. What's the next thing you need in a response? You need a blank line. So that's an empty line, putting an arrow there just to indicate there's nothing there. And then the very next thing you need is the actual content that you're returning. So let's say my favorite file had just the word testing in it. Then we would put that on the next line after our blank line, and that is a complete response. So what I'm saying is, all we have to do to build a basic web server tonight is build something that can receive this line of text and return this text. And then we've built a functioning web server that speaks HTTP that anyone with a web browser can then hit and actually get something from. Sounds pretty simple, right? Cool. Well, let's dive in and actually start coding that. So let me switch over to my desktop. And we are now in Replit. Okay, so I'm also going to start my Pomodoro so that we remember to take a break. So like I mentioned, we're going to go for 25 minutes coding, and then we will take a 5-minute break. I'll take a chance to look at the chat and see if there's anything there that's relevant, or be able to answer questions. All right, so here we are. So if you are in Replit, you'll see that you already have this like class main, public static void main, throws exception. Don't worry about that. That's basically all the code inside of this block will get executed anytime we click this run button right up here. So that is the magic button. In fact, like my server is running. That's why this console over here is emitting things. All right, so if you click run if you've got your Replit open, you click run, you'll see that it starts running and emits the output over here to this thing called console. And then you'll see some, hopefully it will run. There we go. Sometimes Replit can be a little bit funny. I'm going to refresh the screen real quick and see how things look. Run. And see if it works. Not running currently. That's interesting. We'll even try a new browser tab just to see if that is happier. See, this is the real things you run into when writing code. Not even Replit will run for the moment. All right, I'm not sure what's going on there. Oh, yeah, okay, that's actually appropriate. So what's happening is main is getting, so nothing's wrong actually. Main is getting executed, and then there's nothing to execute. So the program immediately exits. So it runs main. So my point is though, when you click run, it's actually going to run the thing that is in this, that's in this block. And then and we'll just work within that. The other thing that we're going to do today is we're going to do everything within a single function. You can kind of see Replit freaking out over here. I don't know what's going on. I think it like auto runs when I save or something like that. We'll see. All right, so the other thing I have in here is I've kind of laid out the structure of our program. We started to talk about this on the whiteboard, if you'll remember. So we said we need to do a couple things. One, we need to start receiving messages. So this is like the equivalent of like taking our cell phone and turning it on so that we can like receive text messages. Then we'll need to be able to handle a new incoming message of, hey, we've got something new coming in. Here's what we do with it. Then we need to read the request side of things. So we talked about the structure of a request being really simple, of this get my fave file HTTP 1.1, but we need to read that from the incoming message, make sure, and then we decide how we'd like to respond. So we're going to start with a very simple like hello world example, which is sort of the canonical or the classic idea of getting a program running is let's do some hello world. And then we will send that response back and then get ready for our next message, because we actually want our web server to stay up and to continue receiving messages and continue responding. And that's sort of the nature of, if you think about the nature of a cell phone, right? You don't just receive one message and then turn the cell phone off. You receive one message, send a response, and you keep going. So this is our entire program. This is at a meta level. I find that like once I've actually mapped out a program in comments, it becomes much easier to write. And so I often start when I'm thinking about a program or a problem that I want to solve, I often start by just sitting down and writing out the pros of what do I think needs to happen step after step. And I'll often put it in the actual program as comments. It even can help to like leave them in there, especially if when reading the code, it doesn't look entirely obvious that what it's doing. All right, so how do we start receiving a message in Java? I did a little bit of pre-work to figure out how Java is going to handle incoming messages. So this is the part that I have gone a little bit ahead in. And so one of the things that we're going to do is we're going to start by using what's called a server socket. I'll explain what those are in just a second here. But here is sort of the ugliness of Java that we have to deal with. So some of you might be thinking right now, like, why in the world did he choose Java of all the languages? Well, the reality is that Java is currently the second most popular language on the planet. There's still a lot of jobs that are available for Java developers, and there are a lot of, in particular, what's called back-end developer jobs, which is where they're building things like web servers and services and that kind of stuff that run on computers in the cloud and actually and provide things like services. So Java is actually a really valuable language to know. All right, so we've got an error already. So I mentioned that we're going to actually have to know how to do some basic imports and things like that. Java likes the way Java imports work. These are libraries that do things for us. And just like you can import things in JavaScript, you can import them in Java as well. So we're going to import the server socket library and open a server socket. So unfortunately, server sockets is like one of the more confusing things we're going to have to deal with today. But you can think of a socket, like where's the other place that you've ever used the term socket? Probably like an electrical socket, right? You think of, got several of them sitting around in here, of a cord that plugs in from one thing to the next, right? And so that's the idea of a socket, is that you have the ability to set up a connection between two things, and the socket allows you to do that connection. And so this has been a networking term that has been around for decades and decades, maybe as long as computers have been around. I don't find it particularly intuitive, but the way that you can think about this, the way you should read this line, is we are going to create a socket and open up that socket on the machine that Replit is running on. So if this is on your local machine, it'd be on your local machine. Replit's actually running in the cloud. So Replit, the machine that's actually executing this code is a server somewhere off in the cloud. And what we're doing when we say try server socket, new server socket 8080, we're actually starting a server. And Replit is really smart, y'all. So I don't know if you noticed, but on the right-hand side of my screen, a little browser window popped up above my console. And that's because Replit actually detected that we started a web server when we ran that line, which is kind of cool. And when I say started a web server, Replit knew that we were opening up a particular socket for connections. And then it opened up this server to show us what would happen if you tried to connect to our server. So here's what's really cool is we're actually going to be able to take this particular URL right here, the basic web server.justmartin1.repl.co, and you'll be able to plug that into any browser and actually see the results of what we're working on in real time, which is pretty neat. I'll go ahead and drop that into chat. Also, just as I was glancing over, I noticed Scott asked if Java is the number 2 language. I'm curious what the number 1 language is. Well, I'll just say 2 things. One, C is currently the most popular language, but there's a lot of like gray area in determining like what is the most popular language. The most like widely accepted way of determining what the most popular language is an index called the TIOBE index, TIOBI. And you can Google the TIOBE index and it'll tell you the top 10, 20, 30 languages. In today's day and age. But there's problems with that way of ranking, just like there's going to be problems with any way of ranking. So that's the browser link that you can use to actually link to our status. And right now, Replit's saying, uh-oh, couldn't reach your REPL. In other words, we have not successfully implemented a web server yet. When we do successfully implement a web server, this little section will change from this error message that the browser is giving to an actual successful response. So we'll actually get to see it. All right, so as REPL just pointed out to us, we have started receiving messages. We are ready to receive messages. One of the things that I like to do as well is put little debug statements like this inside of things. So for example, I want to know when our server has started and when I'm like listening for connections, listening for messages. And so I'll put this line right here. This is a basic print line in Java, system out print line. And then that right there, if you're not familiar with that, that's a new line symbol. And then watch what happens when we rerun the program. We'll actually get a server started listening for messages right here. Now, with this little red line, what that means as well, and you can see up here that run is back to green, the server stopped immediately. So one of the things I mentioned is we actually want the server to continue receiving messages. So we're going to do this little trick. We're going to make a while loop that executes as long as, what a while loop does is it executes as long as the thing inside parentheses is true. And if you put a true inside the parentheses, then it will execute forever. Because true is always true. True never becomes anything else. And so this is actually creating an infinite loop. But in this case, it's what we want. Very rarely is an infinite loop the thing you want when you're writing a program. You usually want to loop over things a certain number of times or loop up until you found something in particular or done some amount of work. With a web server, you actually want it to always be online and receiving messages. And so we're actually going to start by just making this thing run forever. And so now if I hit run, you will see that there's no little red thing after we server started listening for messages. So the program has not completed. You can see stop is grayed out, which means the program's running and I can click stop to stop it. And also the console is not showing a little red dash. It's just showing the output from our current program. All right, so we have a server that has started, but we need to do a couple things. One, we need to handle new messages. One thing that you can't see yet, but has already happened, is our web server has already received a message. We just didn't handle it. Where did the message come from? Right here. This browser nested inside of Replit is hitting our web server and sending a message. And that message looks something like the GET requests that we have over here on the whiteboard. It looks something like that. It says get something from our web server. In just a second, we're going to be able to see what that specific message looks like, which is actually going to be pretty neat. So that is already happening, and we're just not handling it correctly. So we need to start handling it correctly. So how do we do that? So there's another block we're going to put under here. This is another try block. And this time, there's a special message on, or a special function on server socket called accept. And what that does, and we're going to open this try here. I did mention that I have solved some of this problem beforehand, so it'll get us a little ways down the road before we run into things that we have to Google together. So try socket client, server socket accept. This is like the complicated part of the code that we're going to have to write. But what this is saying is the server socket that we opened up. So remember, this says start receiving messages. We need to be ready to, this is like getting the phone number out, or the phone out and turning the phone on. And this is like setting it up to actually receive messages. At this point, when we got here before, we weren't actually receiving any messages. And the nice thing is, once inside of here, we will actually have this variable called client. And the client will actually have messages queued up in it. So it's got messages, we just need to get them out. And so at this point, when we run the program, I'm going to stop it one more time, run it one more time, and you'll see, we should see up here in the top right-hand corner that it fails to again. Oh, I've got to do another import. Socket. That's a separate import. I could import java.net star, which imports everything in the Java.net package, but that would be huge. And this keeps it specific to the things we need. All right, so we're going to hit run, and we should see the browser continue to fail to give us anything up here. Yep. Sure enough. I don't know if we can hit refresh on this somehow. Looks like it's there. Refresh, no luck. All right, so the client has accepted messages, but until we send a response back, the browser does not know what is going on. It's like, what the heck? I sent a message, I didn't get anything back. It's kind of like if you asked your friend out for dinner, like we talked about in our text message example earlier, and said, hey, would you like to come for dinner? And you never hear back from them. And so this is the same thing. The browser has not heard back from our web server yet, and it needs to in order to know what to do and know what happened. All right, so I mentioned that our client actually has some messages like spooled up in it. So what I'm going to do is I'm going to add another debug statement. It says, hey, debug, we got a new message, and the message, let's see if we can do this, plus, I think it's like called client to string. So like we take the client, turn that into a string, we print that out. All right, let's rerun the thing. There it is. So now what this is, see this line right here, this debug, we actually got a new message, and it tells us a little bit about the socket that we got the message from. The message came in from this IP address, it came in on this port, and then it hit this local port 8080, which is the port that we opened up here. I'm not going to explain IP addresses and ports and all that kind of stuff right now, but suffice to say, we have a web server that has started. We're now accepting messages, but we're not yet responding and doing the right thing with them. So let's see how we might go about doing that. So this is the part of Java that like drives me crazy, but Java, unlike some of the more modern languages, has a pretty robust way of dealing with strings. And strings are this really basic concept in programming languages that you use for almost everything, a lot of the time. And yet the way that you actually have to read things from this client is kind of annoying. And I was thinking about how best to explain this. But what we're going to do is we're going to create an input stream reader. Input stream reader. And then we're going to get our client. And we're going to say, hey, get an input stream. Now, we'll need another import here. This will be java.io. IO for input output. So let's get all the stuff from input output because we're going to use several different things from IO. All right, so what this line says is we're going to take this input stream reader and we're going to actually get an input stream from the client. So why not just why didn't this say like client.get request? So the simple answer is that multiple requests can come over in the amount of time it takes for us to read it. And so the way an input stream works is it is like, it's basically giving you the ability to read multiple messages and to scroll back. If we go back to our text message example in your phone, right? You can actually scroll back through the messages, and then that is the input stream, the stream of all the messages. And so as we're going through and responding to this, we're actually going to get all of the messages mashed together, and we're going to be able to read them off one at a time, as opposed to get request, which would imply that there's only a single request that has been sent. That is not necessarily true. There might be multiple requests. One of the things you'll see if you go to view developer tools and actually look at some of the requests and response in the network tab in your developer tools, you'll see that like just a single request of a website sends just a single like load of a website sends dozens or even hundreds of requests. And so we're going to build a web server that can respond to like one request at a time, like a simple web server, but a more complex web server needs to respond to a whole stream of requests all at once. So that's why Input Stream Reader exists. It does not make it nice to use, but hey, there it is. That's what we have to do. Here's the other thing that's kind of annoying around input stream readers is that we can't just get the contents of that stream. We have to create what's called a buffered reader. And buffered reader is basically the buffered reader is basically going to allow us to do is get each line, like basically peel off each message from the stream one at a time. So we'll do that first. The buffered reader br equals new buffered reader. We're already importing that via our import java.io. And then the next thing we will do is then once we read off the buffered reader, we're actually going to need a place to store that, that file as we go through it. So the way this looks, we can create a new string called line. So the way that, one of the nice things about working with Java is that Java strings, once you've created them, they stay the same, that you can't edit them on the fly. There's some subtleties to that, but if you have a string that you want to append things to, it's called a string builder, which kind of makes sense in the sense that you like want to build up a string. So we're going to create this new string builder, which is going to allow us to reconstruct. We're basically going to think of this as like taking each message from the cell phone that you've gotten, the text message, taking each text message and then storing it in something that you're going to be able to read in just a second. You can't read it directly because Java, but we're going to build up a string. All right, so I mentioned a really important fact when we were talking about requests, which is that each request is separated from one another by a blank line. You might remember when I was drawing on the whiteboard over here that I actually had these little arrows that said blank lines. So blank lines in HTTP are very meaningful. They actually are important. You have to use them. And so what we want to do in order to get the very first request off of the stream of requests, we need to look for the first blank line. And this is going to look kind of ugly. So what we'll have to do first is we need to there's a couple of different ways to write this. So we could write this way of line equals, actually we'll just do like, there's actually a couple interesting ways to write this to make it more clear. But what you want is line equals br.readLine. That gives us the first line, and then you want to know whether line.isBlank. And so while we could do it this way, like while not line is blank, then continue to read So we read the first one, and then I'll show you guys an optimization for how to write this a little bit better. But I think this is easier to read the first time. It's like, okay, great. We create this temporary holding variable, called line that holds one line at a time. of our message. Line equals br read line, and then while not line is blank, what do we want to do? So as long as there is more to the message, more to the request, we need to read each individual thing from the request and then store it in our string builder. So we would actually say request builder dot append. That's how you stick something on our request. And you know what I'm going to do? I'm going to change the name of this so that it makes more sense. Whoops. This is a request. Always try to come up with good variable names that are descriptive if you can. So string builder request is a new string builder. So we're going to stick every time we pull a line off that's not blank, we're going to stick it on the request. And then we'll need to read a new one before the loop begins again. So we'll read another one off. And so what's happening is br.readLine is reading a single message each time, or a single line each time. Reads one, store it in this temporary variable line. If that line is not a blank line, then stick it in our request. And we're just going to keep doing that until we build up a simple request. So we should actually now be able to, let's see, oh, that's why I had it named this way. I forgot about this. So you can't actually print a string builder directly. Well, maybe you can. Let's see if you can. I'm going to try, this will be an experiment. I'm looking up my Pomodoro too. We've got about 1 minute left in this 25-minute Pomodoro. So if you have questions, feel free to drop them in the chat and I'll be looking at that in just a second here. So let's do this. System.out.println. Here is the request that we have worked on so hard these last few minutes. And let's see if I can just directly print it out. I'll probably have to do this. But let's see what happens if I just print request builder. I'm gonna hit stop. I'm gonna clear my console right over here so that we just get the output from a single run of our program. I'm gonna hit run. Oh, I was just about to say variable request builder. Did I not rename it? Oh, okay, I didn't yet. Okay. I was just about to say, I haven't run this program in a while. I'm sure there's a bug that will prevent this from running, and boom, there it goes. Okay, interesting. So these are requests. You can see get / HTTP 1.1. Looks pretty familiar, right? And then looks like the other things are slammed onto it. Let me see if I do a request.toString here. Oh, I know what it is. Oh, our Pomodoro just ended. Cool. Okay, so we are now at the point where I know what I need to do here. Let me just do it really fast. Is when we append the line, we also need to append a blank line to the end, or a separator, a new line, a carriage return, as this is called. But so then it ends up getting separated out. So now I'm going to do that, stop, and then we'll take our Pomodoro break right after this. This is actually a great stopping point. Request.toString. I think toString gets implicitly called. For those of you who are Java experts, you'll know better than I will, but I think that gets implicitly called regardless. All right, awesome. So we now have a web server that is running, that receives requests, and then prints those, like stores those the first request there, and then prints it out. So you guys might remember this get HTTP 1.1. And then look what's on our board. Get my fave file, HTTP 1.1. So we are now actually receiving requests. So I'm going to go ahead and hit start break, and we'll start a short break. And I'll take a look at the chat and see if anybody has any questions. So, and I'm going to take a drink because I haven't stopped talking for 40 minutes now. All right, not seeing a lot of questions yet. Whew. jumping back in here shortly to see what else we can build in this short amount of time. I actually feel really good about this. We're 45 minutes into our hour-and-a-half session, so we've got time for 2 more Pomodoros, almost time for 2 more Pomodoros. We should definitely be able to get a web server that actually sends back a reasonable response, and then maybe we can actually send something back fancy, like an image or something like that. So that'll be fun. Yeah. Scott says that learning to do this in Java is on my to-do list. It looks way more complicated than Node so far. Yes and no. I'd say one of the things that Java makes things look really complicated. I heard somebody say one time that Java has basically no curb appeal. It's like a really ugly house. You drive by it and you're like, oh my goodness, why did they paint it that color? And yeah, it has no appeal from the curb, but the bones of Java are actually really good. The Java virtual machine that Java runs on, the Java language has a lot of really nice guarantees and is actually very efficient in running. And that's why a lot of people actually still write code in Java. In fact, like I said, it's the 2nd most popular language on the planet. Forrest asks, what can you do with a web server? That's a great question. I covered this a little bit at the beginning, but I probably didn't expand on it enough. So basically anything that you access through a browser is a web server. And so you can do a lot of different things. The most basic thing that you could do is like host a personal website. So for example, I have my personal website, jessmart.in. This is running on a web server and just serves up some basic HTML and stuff that I've written, stuff that I've worked on, that kind of stuff. But even World of Warcraft or any of the massively multiplayer online video games that you can think of, all of those are actually running web servers as well. Those web servers those servers just run a little bit differently, run slightly different software and way more complicated software than what we're building. And so servers, you can kind of think of servers as a way of like providing information to clients, whether those clients are a game, those clients are an app on your phone. So, or the client is actually a browser, which is probably one of the most common use cases of just having a browser be able to connect to a server. Good question, Forrest. It's probably not obvious to most people just how many web servers exist on the planet right now. It's literally in the millions. And how much of modern technology they're actually powering. And by the way, I should comment on this as we're wrapping up the break. What we're doing right now, where we write a web server from scratch, is likely not anything you will ever have to do as a professional software developer. Only if you're working in a very specialized domain would it be the right thing to do to build a web server from scratch. There are dozens of web servers already, web server software that are fully feature complete, that already exist. You don't need to rebuild those. So like there's probably several running on your computer right now. Some that you might have heard of would be things like Apache and Nginx and all those kind of things. These are actual web servers that are running on your machine and serving up things. So this is not something you would ever do. However, I do find the process of trying to build something from scratch really helpful in understanding how it actually works. So while our little web server is going to be this puny little thing that'll only be able to speak a tiny bit of HTTP, we will understand much better how web servers and web clients, like browsers, work at the end of this 90 minutes, which I think is really valuable. Yeah, Forrest says, so everything you execute from a client goes through a server and then comes back to you. Yes, everything. So like when you send a message on your phone, a text message on your phone, it goes and hits one of Apple's iMessage servers or Android's message servers and then forwards it on to the place that it needs to go. Yeah, they are so prevalent, it's kind of shocking. All right, so that's the end of our 5-minute break. Whew, let's dive right in. We got 2 more of these Pomodoros. That's about 50 more minutes. Man, I'm not used to doing this coding this late at night, so hopefully I can maintain my energy as we finish this up. All right, so right now, as I'm to kind of recap where we've gotten to so far. So far, we've built a web server that actually starts up, it accepts messages, and then it takes the first request that we get off the stream of messages that we've gotten, and it actually just prints that message out. So very, very simple. builds up this one request, prints it out. So the next thing we need to do is decide how we'd like to respond. So the funny thing is, like, we could actually read this request over here and then respond based on what's in the request. That's the way that most web browsers work. So for example, if you go to, I was just mentioning my own personal website, if I brought up the inspection tools here and the network panel, let's see, I'm going to bring that down to make a little space here. And then we refresh it, you'll see all of these requests coming across, and here is the basic request. Request method is get, and it requests the URL, jessmart.in, and it gets a status code of 304 and does all this stuff. So where was I going with that? Right. So normally you would actually look at the contents of this request and you would decide what response to send back. But I think we should start with something simpler. What if we just sent back a simple hello world? Who cares what the actual request was? We're just going to send back something super simple so that we can get this little browser over here doing the right thing. So we mentioned on our whiteboard that this is what a response looks like, right? It has to have, it starts with HTTP 1.1, it sends back 200 OK if it was a good request, it sends back a blank line, and then it sends back the content, which we'll make hello world. So let's see if we can get that coded up here. Again, Java makes some of these things kind of complicated when they don't have to be. I think if I were like a Java expert, I would probably know some simpler ways to write this, but I'm not, and I'm more interested in getting this working and learning than I am in writing perfect code. So we're just going to see if we can, we're just going to use this way of doing it. So just like we had our stream up here, our input stream, we're going to need an output stream in order to send something to the server. And this has the same exact reason that we mentioned as the incoming thing. This is so that I can send multiple responses at the same time. So let's say that like I got back a whole bunch of text messages. I know that this has happened to you, right? You get like 5 text messages from the same person and they're asking you like 5 different questions. And then you send back your responses. You like bundle up your responses into like 5 different responses. You like respond to question 1 in text message 1, question 2 in text message 2, and then it gets really confusing, right? Because text messages aren't threaded and you're like, which thing am I responding to? Same idea, right? So an output stream allows us to send back multiple responses at one time. So we're going to like bundle all of them up into an output stream and then send them. But we're just going to send one response. So it looks a lot more complicated than it actually needs to be. So, but thus the nature of Java and that kind of stuff. There's not a simpler way to do this that I know of. So again, we're going to take our client. Remember, client was this variable up here that I said, this thing is the thing that is accepting and receiving messages. Like it's got all the messages queued up in it. So this time we're going to ask the client for its output stream, which is basically going to say like, hey, give me the ability to send a bunch of stuff. And so when we get that output stream, I'm going to call it client output. And then we're going to put stuff in the output stream. There's a method called write on output streams that allow you to write simple strings. And we'll have to do one little trick that'll make it a little bit more complicated. But remember we said our response starts with HTTP 1.1. So we're going to start there with HTTP 1.1. And then we're going to do 200 OK. There's this thing right here. So there's 200 OK. We need a blank or a carriage return at the end of it. Otherwise, the write will go out. Otherwise, they'll all get packed onto one line. And lines are meaningful when it comes to HTTP. Remember, blank lines mean something. You have to have everything on one line in order for it to be read correctly. That's the agreed upon way we're going to talk to each other. So here's the funky thing. I can't just send this. Well, let's see what happens if I try to. Yeah, so it's going to throw an error here and say, hey, you can't write that. And the reason is that write output streams want to write bytes. Ah, man, computers, why are they so hard? So what it's basically saying is, though, even though we're going to send text, plain text. We're going to encode it in such a way that it can go over the wire, over the internet, in a really fluid way. And the way that we encode things is called bytes. There's a whole lot of history around like why we do that and why they're even called bytes. But in Java doesn't do it for me. It forces me to actually say, get the bytes from this string. So what I've done right here is I've created a string and I've wrapped it in parentheses, and then I can execute methods on that string. I'm going to execute the get bytes method, and then my write will actually succeed at that point. All right, and then in order to actually send the message, we have to do client.flush. I know that's really weird. It's the way that buffers and streams work. When you want to send all of it, when you want to get all of it out of the stream and empty it, in other words, like send it all at once. It's kind of like if you had all of those 5 text messages I was just speaking of, if you had them all queued up and you just wanted to hit send once and have all 5 of them go, that's what flush does. And then the other thing that you have to remember to do is you have to remember to close the output stream. If you leave those open, bad things happen. And I won't go into like exactly how or why that is, but like this is one of the things that Java handles really well, in that it explicitly allows you to leave output streams open and that kind of stuff, whereas Node might close it for you because Node is friendly. But you do have to know how to do that or you'll leave some stuff open. So let's see what happens now. Client flush. Oh, right. Client output. Silly me. All right, so what we're actually trying to do is flush the output of this. And then at the end, we want to close the client. And actually, I'm going to move this client close down to here, because it really isn't related to that, that output stream. So the reason I did that is it's really important to like group related code together. Think of code as like you're writing an essay, and essays have paragraphs. If someone ever like hands you an essay and it has no paragraph breaks, and it's just like page after page after page with no paragraph breaks, it's incredibly hard to read that essay because the ideas aren't grouped together. When you're writing code, you'll notice that I've left lines intentionally between things. Those lines are intentional to create space so that you can see how different sections are related to one another. Like this section reads the request from the string builder. You could even argue that the string builder should be in there with it. And then you could even put a comment above it that says what it does. Read the first request from the client. And so I've done that throughout here. And so I wanted to move this client close because it's the very last thing that you need to do. Remember, we started by getting the client at the very beginning. And so at the very end, we need to close the client, which you would think that, never mind, I'm not going to get into it. All right, so here's our client output flush. Let's hit return and see what happens. Actually, I'm not entirely sure what will happen. Aha! So nothing happened. We have a bug. What have we done wrong? Well, we have done HTTP1 200 OK, but let's go back to our whiteboard. Response, HTTP1 200 OK. Uh-oh, we forgot the blank line, and then we forgot the actual content, which will be on the 3rd line. So let's go ahead and add those in. Back over here. Let's see. So there's a blank line, and now we need the actual content. And so we will do hello world. Let's see what that does. Stop, clear my console, and run. Woohoo! Success! We now have a web server that returns hello world. And check this out. You can actually grab this and drop it into another browser. There it is. Hello world. Massive. No one can miss it. So we built a web server, y'all. It works. It takes requests. It gives back responses. Very, very simple responses. But this is now a functioning web server that actually speaks HTTP. It can take a request. It can respond to it. And it actually works. Pretty cool, huh? So, I mean, yes, I agree with Scott that this is not the prettiest code ever. Java doesn't make this pretty, but ignoring the sort of extra like news and all that kind of stuff you have to do with Java to get this stuff working, it's really not that much code, right? We're at like 50 lines of code here, and a lot of them are comments. So you can write a web server in like 30 lines of code. In fact, I would challenge you, if you already know a language, like it sounds like Scott already knows Node, you could do this in your like a language you're comfortable in pretty quickly, probably in an hour. You're going to have to do some Googling to figure out exactly what packages you'll need, like learning what socket and server socket and that kind of stuff are. But like web servers are actually really freaking simple. Okay, cool. Now we've got one working. Let's not stop there. What else could we output? All right, so this is where we have kind of a choose your own adventure. So we can do two things. I'm going to drop this in the chat. Do we want to try? I think send back an image would be really fun. Or we could change response based on route. So we could actually read the route and like return more than one thing. So I dropped that in the chat. I'm majorly in favor of sending back an image. I think that would be super cool. And then we have a web server that returns an image. And then we can work on change response based on route. But if people in the chat are like, I really want to change response based on route, then we can jump to that. But while I wait to see y'all's comments, I'm going to go ahead and start working on sending back an image. So here we are. So this is our output. Just send back a simple hello world. So what I'm going to do is, all right, Scott agrees. I'm in favor of image too. All right, here we go. So I'm going to like copy this code, comment this code out, and that way we can eventually do like an if then construct around this and then keep all that code uncommented. But just to keep this really, really simple for those of you who are maybe don't have a lot of programming experience, let's just copy paste and let's return something else. So this is where it gets interesting because I don't exactly know how to return an image. So one thing I've done, cool, 4 degrees. Yeah, I think we can get through both given that we have like a Pomodoro and a half left. So I went ahead and attached my favorite JPEG here, which now that I think about it is a really conceited thing to say because my favorite JPEG is a picture of me, which is not true at all. I'm not sure why I called it Fave JPEG. Anyway, I already have a file in the files directory called Fave JPEG, which is a picture of me. And so we can actually, we should be able to actually like read that from the local file system and send it. I'm not sure how that's going to work exactly, but I think, remember I said at the beginning that whenever I'm like trying to tackle a problem and I'm writing code around it, the first thing I do is I actually try to write the comments of what I want to do. So right now I know that, let's see, let's not break up this block. Remember I was talking about paragraphs. Let's keep our little paragraph together. So we're going to send back an image. And so what I'd like to do here is a couple things. I want to load the image from the file system. Then I want to turn the image into bytes, I think. Like, right, we've got these get bytes for all these texts here. There's got to, or for strings, there's got to be a way to do that with images as well. Like maybe it'll already be bytes. I'm not even sure. So we'll find that out. And then the next thing would be we need to set, well, I don't know that we need to do this, but we might need to set the content type. And that would take us into the land of headers, which requests and responses can have headers as well. And so we may need to set the content type, but let's try it without it first. Browsers, like dirty little secret here, browsers are super, super smart. Like they go through all kinds of trickery to deal with like malformed HTTP responses, like responses that don't have enough information in it. So kind of on both sides, like their browsers are taught to be really resilient and like not expect things to be formatted correctly. And so it might be able to take our little image and then and actually figure out what it is and display it appropriately, but we'll see. All right, so let's look up Java load file from file system. Yeah, this is how it works, y'all. The Googles. What I'm going to be looking for is actually the Java docs. I prefer to, like, rather than reading somebody's random web page, I actually prefer to read the actual docs. This is file platform SE7. So one thing to think about when you're when you're looking at documentation is, are you looking at the right version? We're using SE11. There we go. file system. Ooh, in this particular case, I know I just said I would prefer to look at the docs. I am going to open the docs, but this is one case where an example could be really helpful. But let's see. Okay, so file. I'm looking through here. I know this is going really fast. I apologize for the quick scrolling here. I'll try to make it a little bit bigger too. So this is the file class or the file package in Java I/O, which is going to allow me to interact with things on the file system. It says an abstract representation of file and directory path names. I don't think that's actually what I want. I think I want to actually load something from the file system. I bet it's file input stream. Doesn't that look depressingly familiar? Everything's an input stream in ye olde Java. I bet this is going to be it. Yep, look at it. Check it out. A file input stream obtains input bytes from a file in a file system. That's totally what we want, basically. So we need to create a new file input stream and pass in the name of a file. Oh, buddy, I think we can do this. Actually, we can pass in a string named by the path name in the file. Okay, so I could, if this doesn't work, I'm totally going to Stack Overflow this, but let's see if we can do it without a Stack Overflow. So file input stream image equals new file input stream. And then I just mentioned that fave.jpg is in, if you can see this, it is in the same directory as the main.java. So we're actually going to come in here and say, let's get me the thing. So it should look something, yeah, I assume that the machine I'm on will work this way, but fave.jpg should refer to like this very directory. And then I kind of want to print out something about the, just to like make sure I'm actually reading this thing correctly. So maybe something like length or something. Let's see, I'm looking at all these different methods here. Of course it wouldn't have length because it's an input stream. I'd have to like read over the bytes, which would be really annoying. I'm just gonna do toString. That is implemented on literally every single Java object. So toString is always, 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 always a method. All right, let's see if we actually get anything. Probably should have commented these out as well, but okay. So it says it opened the file input stream. I don't know what's in that file input stream, but we're gonna go find out. I think it's already bytes. Is that right? Let's see. So remember our output right here, right? We need to get the output stream. We write the first line. Will the first line change based on sending back an image? No, because we're still sending back 200 okay. Will the second line change? Second line is always a blank line, so no. Will the third line change? Yes, that's where the content goes of the thing that you want to send back. So let's see how this works. Zoomity doom zoom, image dot get bytes, read bytes. Maybe it's already bytes. Maybe I just passed the image. Nope, write doesn't like that. So write wants the actual bytes. We're very close to Stack Overflow action here. Let's see, dot read all bytes? Ooh, that might do it. That might return a byte array. Oh my gosh, if this works, that would be pretty awesome. All right, here we go. So here we go, stop, run. Come on, come on, come on. Oh my goodness, check it out. It's giant, but it works, sweet. Awesome, check out my hair in very, very awkwardly close quarters. Okay, there we go. There's my headphones, much more neutral. That's awesome. So you'll notice that like we changed very little from this top section of like just send back a hello world. We changed like the right line, and we basically had just, it was actually pretty easy to get, right? We figured out how to, we quickly were able to Google and figure out how to load a file and then actually send it back. That's pretty awesome. So now we have a web server that returns a picture of me, which in retrospect, I'm like, why did I do that? But here we are. So there's now it popping up in a different browser, right? I'm like, pretty cool. So now, wow, we've got an additional 5 minutes still left. We should totally start routing. Okay, so changing response based on route. So let's think about how we might do that together. All right, if we go back up to, actually, if we go back over here to our request. So this little section right here is sometimes called the resource. Man, computer names are so bad. Anyway, it's the thing. Give me this thing. And what you can do, the default request when you hit like www.apple.com, it requests /. And so you can use these slashes to like build up a route and to basically separate different portions of the thing you might want. But you don't have to use slashes. That's just one way of doing it. So we could do, for example, we could do /jess and have that return our fave.jpg. We could like have, or sorry, not /, just the word, if you put jess here, then you get fave.jpg. We could do, if we don't know what you put here, then it returns like a sentence or something, like what you looking for. So we could return that if we don't know what it is, and then we could return, if you put hello, we could return our hello world. And that allows us to kind of reuse some of the code we've written. All right, so our goal is to like parse this, like look at this thing and compare it to one of these things. And if it's one of them, then like kind of go. So this is going to be like an if then else, or you could use a switch statement to actually build this up. So let's see how this will work. Yeah, Scott comments that it automatically handles the headers, it seems. Yes, thank you for reminding us of, like we had talked about, we might need to set the content type. So yeah, since it automatically handles the headers, Scott, I think I'm going to leave off explaining what those are. Leave it as an exercise for the viewer. You can actually just go and and look up like what headers are, and they're not very complicated. But one of the headers that you want to look at is one called content type. And apparently, like I mentioned, the browser is really freaking smart, and it actually figures out the content type on the fly. And then I noticed Isaac asks the question, is this the same process for sending live streams? Yes, it is. And so I'll actually, I'll expand on that answer once we finish this Pomodoro, which is about 1.5 minutes from now, and talk more about how a live stream server would work and how you'd actually build that. Okay, so client output stream. So what we want to do, we just talked on the whiteboard about responding to these different things, Jess, question mark, and hello. So where do we find out what is in our request? And the short answer is right here is our request. And if you remember from looking at this over here, our request has a bunch of lines in it. So this is the first line, the debug got new message. So that would be this right here, line 16, that debug got new message. And then we print out here on line 31, we print out the entire request, which is pretty extensive. These are actually some of those headers that Scott was just talking about that are down here below that we ignore and just don't pay any attention to. So, which is perfectly valid. Like you can ignore the headers if you want. So this is what we need. We need this first line of the request, and then we need this second element, or the second section separated by spaces. So let's go down here, and under decide how we'd like to respond, let's write out like our comments of like how we're going to do this. And I'm looking at Pomodoros, and it is going to run out right now. So, whew, okay, I'm going to go ahead and start my break right away. Take a breath, take a drink, and in just a second, we will get into determining how we could route to one of those various things in our last 25-minute Pomodoro. So this has been super fun. I had no idea how easy it would be to write a web server when we got into this, and how, yeah, you could build a pretty robust one at the same time. Some other things to look at if you're like thinking about web servers a lot is there are other HTTP verbs other than get. And so if you wanted to take a look at some of those, you could search for HTTP verbs and read about things like post and put and update and delete and stuff like that. All right, so to answer Isaac's question, and by the way, folks, while we're on our break, if you have questions, feel free to drop them in the chat. I'll try to respond to them over the next 4 minutes or so as I'm taking this last break here, and I'll take questions at the very end before I wrap up the live stream. And also, before I jump into Isaac's question, if you guys are enjoying this, if this is fun for you, actually writing code, then you might actually enjoy Lambda School. So if this is actually, if you're like, how could I do what we're doing right now as a full-time job? Well, we've got a solution for you. So Lambda School is the place that I work. It's hosting this live stream right now. It's a live online school. We train people to become developers, and data scientists are the current tracks right now. And the cool thing about Lambda School is our students don't pay any tuition until they get a job making $50,000 or more. So we really align our incentives with you as the student and help you get that job that you're looking for. We've helped over 1,000 students get jobs at companies all across the US, everything from Apple, Uber, Amazon, Microsoft, others. If you're interested, there's more information in the description down below. There's a link to lambdaschool.com. Feel free to check it out. So, all right, so back to Isaac's question. Is this the same process for sending live streams? So yes, actually what's happening right now as you guys are watching this is I have an application on my running on my computer that's called Streamlabs OBS, or it's a variant of a thing called OBS. And OBS, what that's doing is it's capturing all these different video and audio signals. So it's capturing my face right now via the Canon M50 Mark II that's sitting right there. It's capturing my audio via this lav mic I'm wearing. It's taking all of that and mixing that into a video signal, and it's sending that video signal to a YouTube, what they call an ingestion server. So it's not a web server, but it's a server that takes a specific format, which is video, and then turns it into a live stream that it can present via browser. And the cool thing that's happening there is that it's actually taking every single frame of this video and every single bit of the audio and slicing it into a unique little slice, and then sending that at a very high rate of speed across the internet over to a server, which then reconstructs those into a video, which then, once those are reconstructed into a video, you can actually play them using a video player in your browser, which is mind-boggling when you think about it. Like every single frame, every single thing that I just said was sliced into tiny little bits and then sent over the internet, reconstructed, and then played back for you guys, which is pretty cool. The internet is incredibly powerful, but it's incredibly simple. And that's part of what makes the internet so powerful, is that there's a very simple mechanism for allowing messages to be sent over the internet in a way that's really what you would say resilient. In other words, we don't lose a lot of those messages. So anyway, I think, again, programming is awesome. Computers are pretty cool, except when they're not. And yeah, that's the way live streaming works. Scott, giving a rep for Lambda School. Thanks, man. It's been a lot of fun. I've really enjoyed working here the last couple of years. All right, I'm gonna give myself 30 more seconds before our last 30 minutes. We are coming to a close on this live stream. I'm gonna do like 25 more minutes. I know we're a little bit beyond our 90-minute time frame, so if you need to peace out, that's cool. We're gonna do 25 more minutes and see if we can get, and I may not even go the full 25 minutes. Once we've actually decided, routed, I'll probably stop a few minutes early just to respect what I said at the beginning, trying to make this a 90-minute live stream. Okay, let's do this. Start a tomato. Here we go. All right. So, as I mentioned, we are going to now decide how we would like to respond to a request. So we've got our request up here on line 24, and now we need to decide how we were going to respond to it. So there's a couple things we're going to do here. The first thing we need to do is get the first line of the request, because that's the part that has the meaningful bit, right? The meaningful bit is this. We need to take that off of the request. It's the very first line. So let's grab that, get the first line of the request. The next thing we need to do, is the live stream a little bit laggy? Hopefully not. Okay, good. The streaming servers are not working well. So get the first line of the request, then we need to get the second, I'll call it element, from the first line. And I'll just note that they're separated by spaces. And then we need to compare second thing, which is the path. Actually, I called it the resource on the board, so I'll just call it resource again. Compare the resource to our list of things, and then send back the appropriate thing based on resource. Alrighty, here we go. So diving in here. So this is where we get to do some like fun string time in Java, which from all your experience you've had with me tonight so far in Java, you might already have PTSD about how the heck this is going to work, but we're going to figure it out. So our string builder request has multiple lines on it. I think I might be able to get, can I get the lines that way? Oh my goodness, look at all these appends. Appends equals inserts, last index, length, substring, set length. Oh, I know what we can do. We could do, we already know that if we do this over here, we get out a string with it on the first line. So if we do this, the first line of this should have what we're looking for. And then we could split this by new line. I think that will work. And I'm just going to keep going because why not? And we'll do, give me the first one. So, okay, this is like a terrible, terrible line of code. Like there's a thing called law of Demeter, which is like you shouldn't string together things using dots, multiple things in a row, but we're going to try it anyway. So like first line, string first line equals request.bing, and then we'll do a simple system.out.println to see, did we get the thing that we want? First line. I'm going to go comment this out because that gets pretty noisy sending out the requests over and over and over and over again. All right, let me clear this. Let's stop the web server and then let's hit run. All right, madness worked. So our little like, take the request, turn it into a string, split the string by new lines, and then give me the first element in that array. There's a lot going on in this line, and I could actually, depending on your level of experience with programming, I could take like 15 minutes to just explain what's happening here. So I'm just gonna blaze forward and let you kind of cargo cult type that in, and hopefully it'll work out for you. So we have the first line. We now need the resource. So string resource will take the first line, and then we need to do the same thing. So we can take the same thinking we just applied to splitting up the thing by new lines into splitting things up by spaces. So we'll do split on space, and we'll take the second one this time, and the one indexed. Since it's 0 indexed, that should give us the second one. And then we'll just also do a system out print line to make sure we're doing things right. Print line resource. So now when we run it, we expect over here to see just slash. So let me hit stop, run, expect just a slash. Just a slash, Budzinga. All right. So now let's do this. Oh, you know what? I just thought of something. My idea was that I could do like things like this, /Jess. Oh, we got to do it in a new browser. Oh, let's see, boom. Boop. My idea was that we could do something like this, /Jess, and that the request would look like, it's going to have a slash in front of it. Okay, good to know. Good to know. Tara, I will answer your question in just a second. That's a great question. What does a web server do? Just host data for you? Web servers do all kinds of things. Pretty amazing. Okay, so let's see. Let's close that window. Alrighty, so we've gotten the first line of the request, which is here. We got the second thing, the resource. And now we would like to compare the resource. And again, remember we wrote these comments just a few seconds ago, and now we're going through and actually implementing them. So compare the resource to our list of things. So we want to say if resource equals, and you might remember on the whiteboard, we said we're going to use Jess or hello or we don't know, are the three like options here. So we'll say if /Jess, then let's do this. And if you have not seen an else, oh, cool. I'm like, what is it? How does else if work in Java? I don't remember. Looks like that. Maybe. We'll find out in just a second. I don't know the Java syntax for that, but that's part of using a new language, is you get to learn stuff like that. So /Jess, we'll do /hello as one, and then else we will, there's no clause there. All right, so in the case of hello, we want to move this code up here and uncomment it. And I'll show you guys a refactoring trick in just a second here too. And if we're going to do Jess, then we'll paste that here, uncomment it, and we can uncomment that too. And then finally, if we don't know, then we wanted to return the string what you looking for. We'll even make it what you looking for. Okay, cool. Let's run that and see what that does. And then we'll show like a really quick way to refactor this, and then we will be closing up on the home stretch here on our 90-minute session. All right, cool. So without /Jess or /hello, you get what you're looking for. Let's open a new browser and look at it there, get what you're looking for. Now what happens if we put /Jess? Oh no, it didn't work. /hello. No! Maybe string comparison doesn't work this way in Java. So what happened was, just to point out what we found, we ran into a bug where when we did these comparisons, these triple equal comparisons, this first one did not, even with /Jess, it failed. The second one failed. And so it did this else, and it put out what you're looking for. So now we need to find out two things. One is our resource, what we think it is. So I'll system out println that. And then is the contents of comparing our resource to Jess, does that actually return true or false? And I think this has to do with the way comparisons work in Java. So I'm actually going to not cheat, but go figure that out real quick. So how does string comparison work in Java? There you go. Equals method. I already saw it. Well, it says we can use the equal operator. let's try the equals operator and see if that works instead of using double equals, which is the JavaScript way of doing this. So let's pop over here. We'll change this to a method call called equals, except we'll try and spell it correctly because it won't execute otherwise. And boom. And then we'll do the same here. Instead of doing double equals, which is the JavaScript as well as Ruby and other scripting languages way to do this, we'll do resource.equals, and then let's just rerun it and see if it works. I went ahead and left in this print line on line 40 and to see how that's going to work for us. All right, so now over to our other browser. Where is it? Did I close it? Yeah, I did. All right, pop open another browser. Open this up, what you're looking for. All right, so we've got the resource it was looking for was slash. What if we do /Jess? Huh. The resource is /Jess again. That should have worked. Oh, wow, I must have undid my change. Okay. Well, I guess the other thing we could try really quickly would be /hello. Hello world! Woohoo! We have routing. All right, let me stop and run it real quick, and then we can route to /Jess as well. So it's server starting up. Here we go. So /Jess returns a picture. /hello returns hello world, and everything else, including random stuff, like random stuff, returns what you're looking for. Pretty cool. All right. Whew. Okay, so we are now at 9:32. I know I said I would do 3 complete Pomodoros, but honestly, it is late here and I'm Bush, and I want to take a chance to answer a few questions before we wrap up. And frankly, we've gotten really far. Like this is actually what I wanted to do based on, this is as far as I hoped to get when I was initially planning this out. We have a web server that does routing, that returns an image, that returns different text files and that kind of stuff. And it's really pretty simple. I think you could understand how you could extend this same simple web server to be able to return all kinds of different things. And to this point, it looks like it's returning just files on my file system, but there's a lot you could do with web servers beyond this. So yeah, Scott comments that Java does seem to have some similar syntax to JavaScript. Yep, Java predates JavaScript, and it was one of the 3 languages that inspired JavaScript. Thanks, Tara, for the comment. It's like as soon as I said that we're done, they're all gone. So Tara, to answer your question, what does a web server do? Does it just host data for you? And the short answer is that, Tara, is that web servers do all sorts of things. So one, you could use it to just serve up files like we did today. We served up an image, we served up like different texts based on that kind of stuff. But really any web application, like for example, YouTube that you're running in right now, that you're running in your browser right now, that's running on a bunch of servers that's presenting what we would call a web application composed of JavaScript, HTML, and CSS. And that's built on a web server that does exactly what we just did. So that back and forth where we were having a request gets sent to the server, and the server responds with a response, and then the browser displays what is responded. That's exactly how YouTube works. That's how Twitch works. That's how just about anything on the internet works. And so web servers, anytime you're browsing around the internet and you're going to any URL, you're going to any site, you're on Facebook, all of those things that are being seen in your browser are being served up by a web server. And web servers are just one of the different kinds of servers that are out there. We talked a little bit about live streaming servers and different kinds of servers, gaming servers like World of Warcraft or Fortnite. All of those have literally thousands and thousands of servers hosting those games and feeding those up to what's called the client. And many of those servers actually speak the protocol HTTP, which is the thing that we learned how to make something speak today. So yeah, no problem, Tara. Any other questions? I'm gonna hang out for like 1 or 2 more minutes. And and kind of be winding this down, but happy to answer any more questions you guys have in the chat. One, thanks for sticking around for the whole whole live stream. Those of you who did stick around, and I hope you had a lot of fun. And if you enjoyed this kind of coding exercise, I highly recommend you check out the rest of Lambda School's programs. As I mentioned, you can go down in the description to like lambdaschool.com and click on that, and that'll give you more information about both our full and our part-time programs. But we also have a couple other ways to connect with Lambda School if you're interested. One is you can attend one of our events. We hold regular open houses and previews, and those are an opportunity for you to experience a day in the life of a student. It's like, what would it be like if I was actually at Lambda School? You can actually get that experience before you come. So if you want to attend one of those events, that's on our website. The other thing you can do is you can talk directly to an enrollment advisor. And so sometimes it just feels better to like ask your questions over the phone. We actually have a team that will get on the phone with you and walk you through what it would be like to be at Lambda School. Or you can just jump straight into an application if you're feeling bold, and go to lambdaschool.com. Yeah, so I had a really fun time. I do live stream regularly, so if you follow me on Twitter, I try to live stream once a week. It's been less common or less frequent lately, but today what you experienced is pretty accurate representation of the kind of stuff I do: build stuff, learn together, and try to interact with folks who are on the stream as well. So Scott, Tara, Isaac, Adam, thank you guys for being here. Scott, I totally agree. Java is one of the ugliest languages on the planet, but it's still a really useful language in many ways. So cool. I had a great time, y'all. So I hope you guys continue to